Hi everyone, welcome back to Life Technologies YouTube channel, and thank you so much for watching and supporting our channel. I hope we are all doing good, and please tell us where you are watching from in our comment section. So this is another episode of our Nokia Lab simulation series. Remember, in this series we discuss how to implement different networking protocols or different networking technologies on Nokia routing and switching devices. So in our last episode we discussed how to implement the route reflection on Nokia routing devices. So if you haven't watched that video, kindly check it out on this channel. And just a kind reminder that if you are watching these videos, you've watched even our Huawei routing and switching device lab simulations. You've also watched our IP run series, and you are yet to subscribe. Kindly hit that subscribe button and stay tuned for more upcoming videos and also to support our channel. So this is another episode of our Nokia Lab simulation series, and in this episode we'll be focusing on how to implement dynamic BGP peering on Nokia routing devices. So we know that BGP is a common protocol used especially on medium and large service provider networks. So when you have BGP running on your network, you always have to manually configure the peering session between different networking devices. For example, in this topology, you can see that we have 5 routers. We have the route reflector in the middle, and then we have R1, R2, R3, and R4. So the RR has to establish BGP peering session with all the routers R1, R2, R3, and R4. So if when you are doing this configuration, you always have to configure the peering session both on the local router and also on the remote router. So we have to configure BGP peering sessions on R1, R2, R3, R4, and even RR. And on the RR, we have to specify the peering session to each of these routers. So you can imagine if you have so many routers in the network, you end up having so many BGP configurations on the router. We can avoid this by using the dynamic BGP peering on the service provider network. So on the RR, we configure some dynamic peering sessions that will be established based on the prefix that we have defined on our BGP configurations. So it makes it easy, and whenever we have a new device being added in the network, we don't have to change anything on the RR because we have already defined that prefix. The dynamic prefix that will be used to establish the BGP peering session. So whenever there are packets or there are messages coming in from that prefix, then they will be able to negotiate and establish a BGP peering session between them. So this is what we'll be demonstrating in this lab, and we'll be doing a step-by-step guide. We'll be showing you how to configure step-by-step and also how to troubleshoot and to ensure that you have proper implementation on your Nokia routing devices. So this is the topology that we are using. You can see that we have assigned the system IP. So when you need to do the dynamic BGP peering, it will be good if you have some IP prefixes that are to be used for the system IPs. So when we configure the system IPs, we'll be using IPs from the same subnet. Whenever this subnet is exhausted, we can still add another subnet and define it on the RR. So whenever I've mentioned that whenever you have a new device coming in, you only need to configure that new device with the IP address in the prefix that you have defined on the RR, and then the BGP session will come up without any challenge. For IGP, we'll be using OSPF as usual. We can also use SIS and any other IGP, even static route, but we'll still go with OSPF because it's easy to implement on Nokia routing devices. So we'll be configuring BGP peering session from the RR. So this is the 10.251.200.0 will be our RR, and then we have to establish BGP peering session with all the other routers in the network. So to start us with, we will have to configure the interfaces. So we configure the interfaces, the system interface, and also the physical interface interconnecting the routers. Once you've done that, we'll implement OSPF, and after configuring OSPF, we'll go ahead and configure BGP on the routers and implement dynamic BGP peering on the RR. So to start us with, we can confirm the physical connections. So on the RR, if I show system LLDP neighbor, you can see that we have 4 connections, R1 on C1, R2 on C2, R3 on C3, and R4 on C4. We can also verify on R1, show system LLDP neighbor, you have one connection to RR, it's on C1. On R2, same, show system LLDP neighbor, it's on C2 on RR, and then R3, show system LLDP neighbor, you have C3 on the RR, and finally show system LLDP neighbor. So you have the connections on the RR on port C4. So once you verify this, we can go ahead and start configuring the interfaces. So let me move this one to the side so that we can see the IP addresses. So we'll start by configuring the system interface. We'll start by the RR. So I will quit, exit. Sometimes I use a quit, sometimes exit, but yeah, on Nokia we are using exit command. So when I run show router interface, you can see that we only have the system interface, but no IP address is assigned. So the IPv4 or IPv6 operation status is down. So we need to configure the system IP address first. So I'll configure router interface system and then give it address of, this is 10.251.200.0, mask is 32. So if I run show router interface, you can see that now our system interface is up for IPv4. The next step is now to configure the physical interfaces. So I will configure router, and then we can, in this hierarchy, we can start configuring the interfaces. So I will do interface to R1. I'll give it an address of 10.10.10.0, mask is 31, and I will run show system LLDP neighbor so that we can bind the port. So the port is on C1. Info, you can give it a description, you can configure the other parameters. The next is to configure the interface to R2. So interface to R2, I'll give it an address of 10.10.10.4, mask is 31, and then we need to bind the port. So the port will be C2. So I will specify the port as C2. Info, you have the configuration, exit. Then we need to configure the interface to R3. Address will be 10.10.10.6, mask is 31, and then we assign port C3. Info, you have the configuration, exit, and finally to R4, interface to R4. We'll give it an address of 10.10.10.2, mask is 31, and again we bind the port C4. Info, we exit, can check the interface configuration. So we have interface to R1, to R2, to R3, to R4. If I run show router interface, we expect to get the 5 interfaces. So we have the interfaces. You can see that the admin state is up. The operational state for version 4, it's up because we have assigned IP addresses on the interfaces. So once we've done this, we can go ahead and configure R1. So on R1, show router interface, we don't have any interfaces up. So I'll start by configure router, and then interface system, we need to assign address of 10.251.200.1, mask is 32, and then we need to configure the interface to RR, give it an address of 10.10.10.1, mask is 31, then we need to bind the port C1. So we have the configuration. We'll go to R2. So for R2, we are doing the same. We'll configure router, and then interface system, you give it an address of 10.251.200.2, mask is 32, and then interface to RR, we'll assign the port C1, and then give it an address of 10.10.10.5, mask is 31, exit info. You have your interface configurations. So on R3 we do the same, configure router, so we'll be in this hierarchy, interface system address, it's 10.251.200.3, mask is 32, and then interface to RR, we give it an address of 10.10.10.7, mask is 31, and then we assign the port to C1, exit, and then info to view the configurations. So show router interface, the command we'll use to check the interface is configured. And finally on R4, so on R4 we need to do the same. Start by configure router, interface system address, it's 10.251.200.4, mask is 32, and then assign the port. Now we need to create another interface to RR, address, it's 10.10.10.3, mask is 31, and then bind the port C1. Show router interface, you have the interface up. The next step that we'll do is to do a ping to the interface IPs from the RR. So from here I can ping 10.10.10.1. We are able to ping, we can ping .3 on R4, and then .5, and finally .7. So we are able to ping the physical interface, the interconnect between different routers. You can show router ARP, you'll get the MAC addresses from different routers. So once you've done this, the next step is to now configure OSPF. So we are using OSPF as our IGP, so we'll need to configure OSPF and advertise the networks into OSPF by activating the interfaces under OSPF. So we'll configure OSPF 10. We give it a router ID of 10.251.200.0. This is the mask, the system IP, and then area 0, all routers will be in area 0, interface system, no shutdown, and interface to R1, no shutdown. We'll do interface to R2, interface to R3, and interface to R4. Exit, check the OSPF configuration using the info command. We need to activate the OSPF process, so we no shut down it. So you can see the router ID, the area, and any other parameter that you want to configure. If you want to configure the interface to be point to point, you can always go ahead and do that. So once you've done this, we can now go ahead and configure R1. So OSPF 10, router ID should be 10.251.200.1, area 0, interface system, no shutdown, interface to RR, no shutdown, and finally we need to activate this OSPF process. So no shutdown, info. The next step, we do configuration on R2, OSPF 10 as usual, no shutdown, and then area 0, interface system, no shutdown, then area 0, interface to RR, no shutdown. So with this we are good to go on this router, and we go ahead to implement the same on R3, OSPF 10, area 0, interface system, no shutdown, area 0, interface. So you can either run this command the way I'm doing, or you can go into the specific area and do the configuration. So I can run the area 0 command, click enter, the interface, click enter, and then no shutdown. But again, the easier way is to run these commands the way I'm doing it. So you don't have to keep on exiting, exit all the times. So it's interface to RR, no shutdown. And finally on R4, so you can see the configuration. I need to enable this OSPF process. Info, it's enable. And finally on R4, you need to exit OSPF 10, area 0. So you can do this interface system, no shutdown. Then you have to exit again. But an easier way is to configure it like this: area 0, interface to RR, no shutdown. And then no shutdown the OSPF process info. So these are the configuration. So if I run show router OSPF 10 neighbor, you can see that we are still yet to have a neighbor relationship between the routers. Info. Let's check on RR to see if we have any show router OSPF 10 neighbor. We only have one in full state, the one to R1. So we can check the others, see if they are coming up. Not yet. Let's check OSPF configurations. So R1 interface system, no shutdown, no shutdown. Interface to R3. Let's check on R1. So we'll first check the OSPF configuration to verify they are okay. And then this is .1 show router OSPF 10 neighbor. So you have your neighbor relationship to the RR. We can go to R2 info show router OSPF all neighbor. So we still don't have any OSPF relationship established. Info. So I need to configure the router ID. I'll configure the router ID to be 10.251.200.2. Info. You have the right configuration. Show router OSPF all neighbor. You can see that we now have a relationship that is up. Let's verify on this one. We need to configure the router ID. So you see that on Nokia, when you fail to configure the router ID, one thing, you can configure the global router ID. Let's do this on this router. So I can run router ID to be router ID. We set it to 10. This is on R3, 251.200.3, and see if our adjacent will come up. Show router OSPF all neighbor. It's not yet. So remember, we used to troubleshoot OSPF. If we check show router OSPF status, all status, should be all status. Or you run, sometimes you can run show log ID, then check log 99. So you can see that we have, this is for LLDP, we don't have any OSPF messages. Show router OSPF all adjacency, all neighbor, we still don't have it. So let's go ahead and configure the router ID. OSPF 10 router ID, it's 10.251.200.3. show router OSPF neighbor. We are running all OSPF neighbor. So you can see that our adjacent is up. On R4 SEM, we need to configure the router ID to 10.251.200.4. So once you've done this, we can verify that show router OSPF all neighbor. You have the 4 neighbor relationship. They are now up to R1 to R2 to R3 and to R4. So I can exit and try to ping. So if I try to ping 10.251.200.1, we should be able to .2, we are able to .3. These are basic checks that you always have to do when you are configuring anything. You always have to test. After doing an implementation, you test and then you move to the next stage. If you fail to test, then you may not know where you have the problem. So it's always a good practice that when you are doing implementation, you configure a section or a part of the implementation and then you test to see whether it's okay or not. Then you can proceed to the next stage. So we are okay with OSPF. The next step is now to configure BGP. So for BGP configurations, I'll start with RR. So we need to configure BGP peering session, dynamic BGP peering session on the RR, so that we specify the prefix, and this prefix will be used to establish the BGP peering session with the other routers. So to start us with, I will start by configuring the autonomous system number. It's 65100, and then BGP info. So we are now in BGP configuration. I'll create a group of iBGP and specify the local AS. So local AS, it is 65100. Peer AS, it's 65100. Then we also specify the local address. Local address will be 10.251.200.0. Info, we can specify the family to be IPv4 and VPN-v4, whichever you want to configure. Info, you have these configurations. And remember, this is the RR. So we mentioned that when you are configuring a router as an RR on Nokia, you always have to run the cluster command. So we need to configure the cluster ID on this router to make it to be the RR of the network. So I'll configure cluster, maybe just use the loopback IP 10.251.200.0. Info, you have the cluster ID. Now it will be the RR of the network. And the next stage is to now configure the dynamic neighbor. So one thing that you can do is you can configure the dynamic neighbor limit. So maybe you only need to limit this router to establish 10 peerings, or maybe 3. So let's try 3 and see if the other one will be established. So when you set it to 3, you need to configure dynamic limit, neighbor limit. This is the command. Maybe we set it to 3. So the other one will not be able to establish a BGP peering session, as we will verify when we have done the configuration on the other routers. And then the next stage is to now configure the dynamic peer. So dynamic neighbor, enter, and then we need to merge the prefix. So I'll merge prefix. This prefix will be 10.251.200.0. mask is 24. We are good with that, and then you can also configure the allowed peer AS. So with this, you can specify that I only want to establish BGP peering session with the AS of 65100. All the other routers will not be able to. If they are in a different AS, then they will not be able to establish the peering relationship. So these are the configurations that we need, and with this, we will be able to have all these peers. We don't need to make any change on the RR. Unless we have exhausted this IP, then we can go ahead and configure a new prefix, maybe add another prefix. So on R1, we can go ahead and configure the BGP peering. So it will be autonomous system number 65100, and then BGP, we'll get a group iBGP. Once you've created a group iBGP, we'll specify the local AS. Local AS will be 65100. We will go ahead and configure the local address. So the local address will be 10.251.200.1. Info, we can configure the peer AS to be 65100 info local AS, local address, and then local name. We can configure the IPv4 family. The family is set to IPv4 and VPNv4. And finally, we can configure the neighbor. So it will be neighbor 10.251.200.0 no shutdown info. And one thing that you can always do is to give the description. So I can give it neighbor 10.251.200.0 description. You give it a description to RR. So if you have many peerings, it will be very easy to identify which neighbor you are talking about. So these are the configuration. We expect that we should be able to establish show router BGP neighbor or show router BGP summary. You can see that our peering relationship is already up. On the RR show router BGP summary, you can see that we have one peering and the flag is set to dynamic. So this is how easy it is, guys, to implement dynamic BGP peerings. So we'll go ahead and do it on R2, R3, and R4, and then we can verify that all our sessions will be able to come up, but only in this IP prefix 10.251.200.0, mask should be 24. So on R2, we'll do the same, exit, configure router. Oh no, we are already in router BGP. We need to start by configuring the autonomous system number. We set it to 65100 BGP group. Then we configure the group iBGP. Maybe I can copy some configs from here. Let me see info. Apart from the name, we can copy this. And then we need to also copy the peering session. And one thing that I will only do is to configure the local address to be 10.251.200.2. Info, we have the configuration, exit, show router BGP summary. You can see that our peering session is up. On the RR, we expect to have an extra dynamic session, and you can see that now we have two, and they are all set to dynamic. So you can see how easy it is, very interesting. Finally, we do on R3, exit. We need to configure the autonomous system number to 65100 BGP. We create a group of iBGP. Local address should be 10.65100 as local AS. Local address will be 10.251.200.3, and then family, we have IPv4 and VPNv4. Then we need to configure the peer info. So show router BGP summary. This is the command that you use to check the peering session. It's still idle. Let's give it some time. Let's check the configurations again. We have, so we need to specify the peer AS 65100 info show router BGP summary. You can see that it's now established. On the RR, we expect to have another session. So we have 3 dynamic sessions. And finally on R4, remember on this router we configured a maximum of only 3. So when we configure R4, we don't expect the peering session to come up. BGP, we need to start by configuring the autonomous system 65100 BGP. group IBGP, local AS 65,100, peer AS should be 65,100. This is IBGP, and then we need to configure the local address. Local address will be 10.251.200.4. info to check what we have already configured. I will configure the family to be IPv4 and VPNv4. And finally, we can specify the neighbor. Info, these are the configurations. So if I run show router BGP summary, you can see that it's in active state. Let's see if we can see any log messages. Show log ID 99. So you can see here clearly that it's reporting that the closing connection reached dynamic peer limit of 3 for BGP group IBGP. So it's clearly telling us that we cannot establish a BGP peering session because we have reached the limit. What we can do is to change the limit on the RR, and we should be able to have another session coming up. Info. So what I can do is I'm in the group, so I can dynamic limit, we set it to 5. Info. So we are now at 5. Let's see whether our session will come up. It's still active. Let's see on the RR. Still 3. And now we have 4. So we have another extra peering that has come up on .4, and you can see that it's still dynamic. Dynamic meaning that we have established dynamic BGP peering relationship based on the prefix that we have defined on the router. So this is how easy it is to configure BGP peering, dynamic BGP peering on Nokia routing devices. These are the configuration. You can configure the dynamic neighbor limit. You can configure the dynamic neighbor and also match the prefix. I'm sure we should be able to match the prefix. So let's see dynamic neighbor, and then we can merge info. See if we are allowed to add another prefix 10.251.200. This one should be .201.0. mask is 24. Let's see info, exit, then info. So you can see that we have 2 prefixes. So you can add as many prefixes as you want, and it will be very easy to implement the BGP peering session between the different routers. So once it's come up, it will send the messages, they will exchange the messages, they will negotiate, the TCP will take place, and then we'll have dynamic BGP peering relationship established on the routers. I hope you've enjoyed this session. If you've enjoyed it, leave us a comment, like this video, and also feel free to share with your friends. And again, if you are yet to subscribe, just hit that subscribe button to support our channel. And also, thank you so much for watching, and please just remember to subscribe to our channel if you are yet to. Thank you and bye. See you in our next episode on our Nokia Lab simulation series.